Hello. In this review, we'll talk about the American air-to-air missile, AIM-54 Phoenix. This missile is another product of the Cold War, developed specifically to destroy Soviet bombers and anti-ship missiles, in order to significantly enhance the safety of American aircraft carriers. However, it went down in history as an ambitious, expensive, and ultimately useless missile that in fact, never really saw combat use. Today, I'll cover all of this, its capabilities, the modifications that were made, and why it ended up the way it did. Before we start, don't forget to subscribe to the channel and click like, it helps us make better content. Let's burn. The story of the AIM-54 Phoenix missile is closely intertwined with the histories of other missiles and aircraft developed during the 1950s and 1960s, many of which have already been covered in previous reviews on the channel. I recommend checking out the videos on the F-111 fighter bomber. Link will be in the description. The history of the Phoenix missile began with 3 other failed projects of the US Navy. The Phoenix was specifically intended for them and was never used by the US Air Force. The starting point was 1958, a truly significant year, as all 3 failed Navy projects connected to the missile were initiated in that year. By the late 1950s, the US had grown increasingly concerned about Soviet bombers, along with cruise missiles and later anti-ship missiles, which posed a potential threat to aircraft carriers from long distances. I mentioned this in the review of the F-111 fighter bomber. In fact, the F-111 was developed starting in 1958 precisely for this purpose: to intercept and destroy bombers before they could get close enough to launch their missiles. But to do this, a suitable air-to-air missile was needed, one capable of engaging slow-moving bombers from a distance of 200 kilometers or more. Ideally, it would also be able to intercept launched cruise and anti-ship missiles. In 1957, the US Navy officially raised concerns and issued a requirement to explore the possibility of creating such a missile, along with a corresponding long-range interceptor aircraft equipped to detect and engage these threats. This demanded the simultaneous development of a new missile, radar system, and aircraft. In 1958, development began on a new air-to-air missile designated the AIM-10 Eagle. The contract was awarded to the Bendix Corporation. According to the design, the missile would be about 5 meters long and weigh nearly 600 kilograms with its booster. It would feature a solid fuel rocket booster to accelerate it to Mach 3.5, after which a second-stage solid fuel sustainer motor would kick in, pushing the speed up to Mach 4.5. This high speed was also to be achieved by having the missile climb to an altitude of up to 30 kilometers after launch and then dive toward the target, using kinetic energy to its advantage. The missile was designed to engage targets at a range of 200 kilometers. The guidance system was also quite ambitious. The missile would be equipped with a semi-active radar seeker for mid-course guidance, using the carrier aircraft's radar to track and correct its flight path. For the final stage of the interception, it would switch to an active radar seeker for terminal homing. As you can imagine, this was no simple task. A matching carrier aircraft was required, featuring a powerful radar capable of detecting and tracking targets at long distances. Once all this was assessed, requirements for a new aircraft were drawn up. In 1959, Douglas Aircraft presented its concept for an interceptor, the Douglas F-6D Missileer, also known as a Fleet Defense Interceptor. According to the design, it would carry 3 Eagle missiles under each wing and would be equipped with a pulse Doppler radar capable of detecting targets at up to 220 kilometers. It was the first radar of its kind that could simultaneously track up to 8 targets at a distance of 150 kilometers. Most importantly, it would be able to guide the new missile during the mid-course phase of flight. A year later, in 1960, after assessing the enormous cost of developing both a new aircraft and a new missile, the US Navy decided it was not practical. Building a specialized aircraft for a single missile and a specific mission was deemed unjustifiable. As a result, both the aircraft and missile projects were cancelled, they became history. Another factor influencing this decision was the ongoing development of the F-111 fighter bomber, and in the same year, the Navy joined that project. I covered this part of the story in the F-111 review. While things became more or less clear with the aircraft, the situation with the new missile remained uncertain. It was still very much needed. Hughes Aircraft had been working since the 1950s on its Guard II missile, which would later be designated the AIM-4 Falcon. In 1957, the company received a contract to develop its version of a long-range missile, initially designated GAR-9. In 1963, when the US standardized its missile designation system, it was renamed as AIM-54 Falcon. This missile was designed to intercept airborne targets at ranges of over 100 kilometers. However, in the mid-1960s, that project was also cancelled, partly due to its shortcomings. During the development of the Navy's version of the F-111, it became clear that a new fire control system and a pulse Doppler radar would be needed to use a missile comparable to the Eagle. Therefore, starting in 1962, Hughes Aircraft began developing such a system. It was called the ANAWG-9. This system was installed on the F-111B. It could detect up to 18 targets simultaneously, track up to 6 targets at once, and guide up to 6 missiles at those targets. When the U.S. Navy abandoned the Eagle and Missileer projects in 1960 and joined the F-111 program, they set a new goal: to develop a missile that would be cheaper to produce but would offer performance comparable to the AIM-10 Eagle and could potentially be used with the F-111B. Hughes Aircraft was again awarded the development contract. That's why they also developed the compatible radar and fire control system. The missile was initially designated the AIM-11. In 1963, following the U.S. military's new designation standards, the missile was renamed AIM-54 Phoenix. Later, this first version became known as the AIM-54A. Hughes based much of the Phoenix's design on the AIM-47. Although the AIM-47 project was eventually cancelled, it served as the foundation for the Phoenix. Visually, the two missiles differ mainly in the length of their wings. As for the internal systems, key technologies had to be carried over from the Eagle concept: a combination of semi-active and active radar homing guidance, a solid-fuel rocket motor enabling speeds of around Mach 3.5, and the ability to engage targets at ranges of 150 kilometers or more. The AIM-54 was first sent for testing in 1965. At that stage, it was more of a dummy, without a guidance system or fire control system. The goal was simply to evaluate the missile's flight capabilities. By that time, it was already clear that the development and production of the missile would be extremely expensive. However, political factors and the arms race came to the forefront. The Soviet Union was aware that the US was working on such a missile and understood its potential capabilities. Meanwhile, the US knew that the Soviets were developing the Kh-22 anti-ship missile, which could pose a major threat to American aircraft carriers. So, canceling the Phoenix project was not an option. They had to see it through. The AWG-9 fire control system, along with its radar, was first installed on an A-3 Skywarrior carrier-based bomber. In 1966, the first tests were conducted, during which the system successfully acquired an airborne target and guided a Phoenix missile toward it. That same year, the fire control system and radar were installed on the F-111B. In 1967, for the first time, tests were conducted with the F-111B and the AIM-54 together. While the results with the new missile were satisfactory, the results with the F-111B aircraft were disappointing. In 1968, the U.S. Navy withdrew from the F-111 fighter-bomber project. As I mentioned in the F-111 review, the Navy shifted focus to the Naval Fighter X, or Naval Fighter Experimental Project, abbreviated as VFX, which would eventually become the F-14 Tomcat. Jumping ahead a bit, the F-14 and AIM-54 would become inseparable partners throughout their service life. The Tomcat would be the only aircraft to carry and launch the Phoenix missile. The full history of the F-14's development is a topic for another review, but it's important to note that the Tomcat was specifically designed around the new missile. It had to be equipped with the AWG-9 fire control system and pulse Doppler radar. Transferring the system from the F-111B to the F-14 wasn't straightforward. The original system weighed around 900 kilograms, which was too heavy for the F-14. Therefore, it had to be redesigned, reducing the weight to 576 kilograms and shrinking the component sizes. The upgraded radar could now detect not 18, but 24 targets simultaneously. While the Tomcat was still under development, missile testing continued using F-111B prototypes. In 1969, 2 Phoenix missiles were successfully launched at 2 separate targets at the same time, demonstrating the system's multi-target engagement capability. By 1970, a total of 29 missile launches had been conducted, most of which were successful. This encouraged the U.S. Navy to sign a contract with Hughes Aircraft for mass production of the AIM-54 Phoenix, even though the missile had not yet achieved full operational capability. One major issue was the cost. A single AIM-54 was priced at just under $1 million at the time, an astronomical figure for a missile in 1970. Adjusted for today's values, one Phoenix missile would cost a little over $8 million. Reducing the price became a priority. The year 1972 was significant for the AIM-54. The first tests of the Phoenix missile launched from the F-14 Tomcat began. Later that year, multiple simultaneous missile launches at multiple targets were successfully carried out. Iran placed an order for these missiles, ordering more than 700 units. However, by 1979, only 274 missiles had been delivered. Iran also received F-14 Tomcats, from which the Phoenix missiles were launched. In 1979, after the U.S. Embassy in Tehran was attacked, all further deliveries of missiles, aircraft, and other military equipment were cancelled. Nevertheless, the aircraft and missiles already delivered remained in Iran's possession. As a result, Iran became the only foreign operator of the AIM-54 Phoenix, and the only country to use it in real combat, mostly against Iraqi aircraft during the Iran-Iraq War. In 1973, tests were conducted that demonstrated to both the United States and the Soviet Union just how formidable a weapon America possessed. From an F-14 Tomcat, 6 Phoenix missiles were launched at 6 airborne targets, 2 BQM-34 drones and 4 QT-33 target drones. The missiles successfully hit 4 of the 6 targets. The 2 missed targets were due to specific technical reasons, but overall, the tests clearly demonstrated the capabilities of both the missile and the fire control system with its radar. The tests showed an 88% success rate in hitting targets, which was considered an excellent result. By that time, further refinements had reduced the missile's production cost to just under $500,000 each. Starting that same year, the AIM-54 Phoenix began serial deliveries to the U.S. Navy. In 1974, it was officially adopted into service. A total of 2,505 missiles were produced in the baseline AIM-54A configuration, along with around 50 units of the AIM-54B and various training missile versions. Across all modifications, just over 5,000 missiles were manufactured. Production ended in 1992, and the Phoenix was retired from service in 2004, 2 years before the retirement of the F-14 Tomcat itself. By the time the last version was being produced, the cost per missile had risen to about $1.3 million. Throughout its service life, the U.S. Navy only recorded a few combat launches of the Phoenix, and even then, it's unclear whether any direct hits on enemy targets were achieved. The AIM-54 faced several problems. It was extremely expensive, making it difficult to conduct training launches and exercises, especially given that it could only be launched from one aircraft model, the F-14. Only a limited number of specially trained pilots could actually use it. By the 1980s, it became clear that the Phoenix was effective only against a limited set of target types. Newer missiles produced by the Soviet Union outclassed the Phoenix in many respects, making it less viable for interception tasks. Heavy bomber threats were becoming less relevant as military doctrine evolved. After the collapse of the Soviet Union, the need for a missile like the Phoenix largely disappeared altogether. The AIM-54 was replaced in service by the AIM-120 AMRAAM missile. That's the story of the Phoenix missile. Now, let's take a closer look at its design and capabilities. The AIM-54A Phoenix missile is quite large and heavy. It weighs 443 kilograms, has a length of 3.96 meters, a diameter of 0.38 meters, and a wingspan of 0.92 meters. The missile's surface is coated with a 4 mm layer of thermal insulation to prevent kinetic heating of the body beyond 200 degrees Celsius. The nose section is made from ceramic material. The Phoenix uses a combined guidance method and relies entirely on the fire control system and radar installed on the F-14 Tomcat. In the nose of the missile is a seeker that combines semi-active and active radar homing. While the F-14's radar could detect targets at distances of over 200 kilometers, the missile itself in its basic version was nominally capable of engaging targets between 3.7 kilometers and 160 kilometers away. Its effective engagement range was around 136 kilometers. During the cruise phase, the missile was guided using its semi-active radar seeker and autopilot. The F-14's radar would periodically update the missile's course to keep it locked on the target. However, there was an important limitation. If the missile lost connection with the aircraft due to heavy jamming, and if the link was not restored within 14 seconds, it would no longer be possible to guide the missile. After losing guidance, the missile would continue flying forward blindly because the autopilot needed constant coordinate updates to function properly. At approximately 18 kilometers from the target, the missile's active radar seeker would engage, allowing the Phoenix to independently track and home in on the target from that point onward. Behind the seeker was the control system, which in the basic version was based on analog electronics. Following that was the warhead section, housing a 60 kilograms high explosive fragmentation warhead. The Phoenix was equipped with 3 types of fuses: radar proximity, infrared, and contact fuses. Upon detonation, fragments would disperse within a 15-meter radius. Next came the propulsion system, a Mark 60 Mod 0 solid fuel rocket motor. The Phoenix could reach speeds up to Mach 3.9. It's about 4,800 kilometers per hour or nearly 3,000 miles per hour, depending on its flight altitude. Externally, the missile was fitted with wings for lift and aerodynamic control surfaces in an X configuration at the tail. The Phoenix could be launched at speeds of up to Mach 1.6 by the carrier aircraft. After launch, the missile would climb to altitudes of up to 24,000 meters before diving down toward the target. This high arc flight profile allowed it to conserve energy, as the rocket motor only burned for less than 30 seconds. For much of the journey to the target, the missile would coast on inertia. However, the basic version of the AIM-54 had several shortcomings. It had poor resistance to electronic countermeasures. Its onboard electronics were prone to occasional failures. Guidance accuracy was sometimes lacking. One significant issue was the proximity fuse. During testing, missiles could pass close to targets without detonating, resulting in missed kills because the warhead failed to trigger. All of these flaws required major improvements to the missile's design. In the mid-1970s, work began on a simplified version of the missile, the AIM-54B Phoenix. Lighter materials and other simplified components were used in its construction, with the primary goal of reducing the missile's cost. However, the AIM-54B was never mass-produced. Only a few prototypes were built, and it mostly served as the basis for training missiles. The next version was designated AIM-54C Phoenix. Development work started in 1977, with prototype testing beginning in 1979. The missile reached operational readiness in 1984 and was officially adopted into service in 1986. The AIM-54C featured digital electronics instead of analog systems. It had a command inertial guidance system to adjust its trajectory during the cruise phase, enabling it to follow more complex flight paths. It also had an improved active radar seeker for terminal guidance. This version required 15% fewer components compared to the original AIM-54A. It was equipped with an improved solid fuel rocket motor, the Mark 47 Mod 1, allowing it to reach speeds of up to Mach 5. The nominal maximum engagement range increased to 184 kilometers, with an effective range of about 150 kilometers. The AIM-54C had better resistance to electronic countermeasures, improved targeting of smaller-sized threats, and a more effective warhead. It could climb to a maximum altitude of 30,000 meters during flight before diving down toward its target. The missile seeker and control systems were upgraded, and the fusing system was improved. These enhancements significantly increased the cost of the missile, but also improved its accuracy by 25% compared to the original Phoenix. The missile's dimensions remained the same, but its weight increased to 463 kilograms. Another upgraded variant was developed, the AIM-54C ECCM sealed. ECCM stands for Electronic Countermeasures. This version had even stronger resistance to jamming and no longer required coolant conditioning during flight when in target acquisition mode. Its nose section was hermetically sealed, allowing the missile to be launched in the rain and to engage sea-skimming anti-ship missiles flying very low over the ocean surface. This protected the sensitive electronics from moisture. The AIM-54C ECCM sealed was introduced into service in 1988. Its seeker and control systems were further improved, and it was equipped with built-in self-test functions. The F-14 Tomcat could carry up to 6 Phoenix missiles, 4 mounted on under-fuselage pylons and 1 under each wing pylon. In 1982, the company Raytheon joined the Phoenix program, and part of the production was handled at Raytheon facilities. The history of the Phoenix missile came to an end in 2004. Its greatest success was arguably setting a high technological benchmark for the Soviet Union to compete with, rather than actual combat achievements. The US Navy never really had the opportunity to show off the Phoenix in combat, while Iran, ironically, did. Ultimately, the Phoenix was another product of the Cold War, more political in nature than purely military. Well, that was the story of the AIM-54 Phoenix missile. I hope you found this video interesting and informative. Don't forget to subscribe to the channel and click like. That's all for now. Wishing you clear skies. Goodbye.